Hi everyone, in this video we're going to be doing A-Level Further Maths 9231 paper 14 for the Pure Maths 1 May June 2025. This paper is 2 hours long, so we'll try to finish within that time limit. So let's head on to the first question. Okay, so for the first question, we have to use our MF19 to find this expression in terms of n, and we also have to simplify our answer. Okay, so in order to do this, let's first write down this summation in full. And one thing you have to know with summations is just like integrals, like you're differentiating 2x plus 1. You can also like split this, so you can, differentiate 2x and you can add it with the derivative of 1. So we're also gonna do the same thing here. We're going to split the summation into two summations. So this would be r equals to 1 all the way to n of 2r plus the same r all the way to n 1. Okay, so let's take out the constant term, because just like when you're integrating or differentiating, you have to take out any constant terms that are not in terms of r. So let's take out 2. So this is the final summation that we have to determine. Okay, so for r equals to 1 all the way to n, the summation of r, can head on to our MF19. And here we're given the formula for this exact result right here. So we're going to substitute that half n times n plus 1. And then for the summation of r equals to 1 all the way to n of 1, we just multiply 1 by n. And you can use this formula for any other constant inside a summation. It would just be k times n, or whatever the upper limit of the summation is. Yeah. So also take note of that. Now we can begin simplifying. So the 2 and 2's cancel out, so you get n times n plus 1 times n. And you can see we can factor out n. It's a common factor, so this would be n times n plus 1 plus 1. And this is just n squared plus 2n. So this is the final answer for this part. Let's go on to the next part. Okay, so for this part, we're supposed to show that this rational function is equal to the difference of these rational functions. Okay, so to do this, a lot of us would just go on to split this into partial fractions, but that's gonna take really long. So instead, let's do it, from the right-hand side to the left-hand side. So we start from here and then we go to here. So let's write down our right-hand side. And now we're going to make the denominator the same if you want to combine this into a single fraction. So this would be r squared plus 1 times r squared plus 2r plus 2. So for the first fraction, this would be multiplied by this, and hence the numerator would be r squared plus 2r plus 2. And then minus, since you're multiplying by r squared plus 1, this will also be multiplied by r squared plus 1. So this is r squared plus 1. Now we can open up the brackets and simplify the numerator. So the r squares cancel out. So the final answer will be 2r plus 1 over r squared plus 1 times r squared plus 2r plus 2. So we can write shown here. So this is our final answer for this part. Let's head on to the next part. Okay, and now we're going to have to use the method of differences to find this expression. So this expression inside the summation is the exact same expression that we re-expressed in terms of like a difference. And if you want to use a method of differences, that's the first requirement, is that you should express it in terms of a difference of like two functions, okay? So let's write it as that using our answer to the previous part. So this is 1 over r squared plus 1 minus 1 over r squared plus 2r plus 2. Okay, and to make this easier, we're going to complete the square for the second term, 1 over r squared plus 2r plus 2. So completing the square, that gives us r plus 1 squared minus 1 squared, that's minus 1, plus 2, which is just plus 1. And as you can see, this fits very nicely, into this form. So like n minus n plus 1, something like this. I hope you guys get what I'm trying to say. Like the r, the first term would be like 1, and then the second term would be 2, and so on. This is the ideal setup that you should have before carrying out a method of differences. So now let's start the actual thing. Okay, so first let's substitute r equals to 1. So this would be 1 over 1 squared plus 1, that's 2. Then minus 1 over 1 plus 1, 2, 2 squared plus 1, that is 4 plus 1, that's 5. And then plus, now let's substitute r equals to 2. So this would be 2 squared, which is 4 plus 1, that's 1 over 5. And then minus 2 plus 1 squared, that's 3 squared. 3 squared is 9 plus 1, that is over 10. And if you've realized the pattern by now, you should know the next term when you substitute r equals to 3 would be 1 over 10. And the next term would just be 3 plus 1 squared, which is 4 squared. And 4 squared is 16. And then 16 plus 1 is 17. So these terms will cancel out. Now let's evaluate the last two terms. Okay, so the last two terms, you substitute r equals to n minus 1. So you get 1 over n minus 1 squared plus 1 minus 1 over n minus 1 plus 1. That's n squared plus 1. Now let's substitute r equals to n. You'll get 1 over n squared plus 1 minus 1 over n plus 1 squared plus 1. So as you can see, these terms obviously cancel out, and so will this, because this will be the term for r plus 1 squared when you substitute n equals to r equals to n minus 2. Yeah, so all the middle terms will cancel out, and we will have only 1/2 and minus 1 over n plus 1 squared plus 1 as our final answer. So this is the final answer for this part. Let's head on to the final part. So for this final part, we're supposed to deduce the value of this summation from r equals to 1 all the way to infinity. Okay, so to do this, let's take a look at our expression for summation from 1 all the way to n. So we can use this to find this. So we just have to find the value as n approaches infinity. So basically, as n gets bigger and bigger, the numerator becomes infinity, so it's just 1 over infinity. I mean, the denominator becomes infinity, so this becomes just 0, and then you get 1/2 minus 0, which is just 1/2. So answer is just 1/2. So this is our final answer for this part. Let's head on to the next question. Okay, so now we're supposed to prove by mathematical induction that for every integer n more than or equal to 2, not more than or equal to 1, as we're used to, we're supposed to prove this result. Okay, so for proof by induction, the general process is you start by proving the initial case. So in this case, we have to first let n goes to 2. And then this would be, d squared over dx squared, okay, of x ln x. So basically, this is just the second derivative of this. So to find that out, you're going to have to differentiate this expression twice. So let's differentiate x ln x. So we just use the product rule. Okay, so first we keep x, multiply the derivative of ln x, that's just 1 over x. Then we add the derivative of x, that's 1, and keep ln x. So this will give us dx 1 plus ln x. And now to differentiate this, you differentiate each term separately. So ddx 1, that's 0, and then ln x, that's 1 over x. And now we're going to have to prove that this is also equal to the right-hand side, okay? So this is also the same as minus 1 to the power of 2, that's 1. Then n minus 2, that is 2 minus 2 factorial. So that just gives you 0 factorial times x to the power of 1 minus 2, which is to the power of minus 1. So this is so as you can see, this right-hand side is just equals to 1 over x. And so we can say, since left-hand side is equals to right-hand side, case for n equals to 2 is true. Okay, now we are going to make the assumption. So we're going to assume that for n equals to k, the above statement is true. So just write it down. Just replace all the n's with k. So dk over dxk ln x is equal to minus 1 to the power of k times k minus 2 factorial times x to the power of 1 minus k, where k is a positive integer. More than or equal to 2. So we make this assumption, and now we're going to substitute, and we're going to let n equals to k plus 1. Okay, so let's substitute that. So dk plus 1 over dxk plus 1 of x ln x. This is basically the same as the derivative of dk over dxk of x ln x. Yeah, so like the third derivative is basically the derivative of the second derivative, and the second derivative is the derivative of the first derivative. So like we're using this logic in here. Okay, so now let's substitute the expression for this in our assumption. We already did it, so that's just 1 minus k to the power of k times k minus 2 factorial x minus x to the power of 1 minus k. Okay, so to differentiate this, we're going to take out this whole term because this is a constant. It's not in terms of x. So this would just be 1 minus k to the power 1 minus 1 to the power of k times k minus 2 factorial. And we're just going to differentiate x to the power of 1 minus k. Okay, so to do that, we're just going to use our power rule. So that it's just this, take your initial power, 1 minus k, and then we minus 1 from the initial power. So you'll just get minus k. Okay. And now, let's see. So our aim in here is to manipulate this such that it is in this exact form. So instead of n, every term would be replaced by k plus 1. So that's our main goal here. So first thing we can do is to incorporate this into the factorial function. So the first step is to factor out minus 1 from 1 minus k. So this will give you 1 minus k, minus 1 to the power of k times minus 1 times k minus 1 times k minus 2 factorial times x to the power of minus k. We can actually rewrite as 1 minus k plus 1. Yeah. And then for k minus 1 times k minus 2 factorial, that's the same as 5 minus 4 factorial. Like this is an example of it. This is just 5 factorial. Okay, so this would just be, let's combine the minus ones first. So using our log indices, this is minus 1 to the power of k plus 1. And this is just k minus 1 factorial. This is just x to the power of 1 minus k plus 1. So let's check if we have, expressed in the general form. Yeah, minus 1 to the power of k plus 1 times, k, okay. We have to express in terms of n minus 2. So basically k plus 1 minus 2, which is easily doable. So this is just 1 minus 1 to the power of k plus 1 times k plus 1 minus 2 factorial times x to the power of minus 1 minus k plus 1. Okay, so it's fully in this form. Now we can say since true for case when n equals to k, it's also true for n equals to k plus 1. Okay, and then here we can finally conclude that by principle of mathematical induction, the above statement is true. So this is our final answer for this entire question. Let's head on to the next question. Okay, so this question, we're told that the points A, B, and C have these respective position vectors. So this is for point A, this for point B, this for point C, respectively relative to the origin. So this is OA, this is OB, and this is OC. For the first part, we're supposed to find the equation of the plane ABC, giving your answer in the form of AX plus BY plus CZ equals to D. So we're supposed to give the Cartesian equation of the plane. Okay, first of all, in order to do this, let's make a sketch of plane ABC. So this is A, B, C. And this is like a sketch of the plane. And now let's spot two direction vectors that from which we can take our, let's just spot two direction vectors. So one of them is AB and the other one is CB. Okay. So let's use these two direction vectors. Okay. So let's find these out. So AB just be OB minus OA is equal to minus 5, 3, 1 minus OA, which is 0, 2, 3. And then AB would be equals to minus 5, 3 minus 2, that's 1, and then 1 minus 3, minus 3 plus 1, that's minus 2. So this is AB. Now let's find BC. So BC, okay, you know what? Let's not take BC, let's find AC instead. Because like the one condition for for choosing the lines in your plane is that they should be originating from like one common point. Okay. Yeah, so let's find AC instead. Okay, so finding AC, we get OC minus OA. So OC is 1, 2, 5 minus OA, that is 0, 2, 3. So this would give you 1, 0, 2. Okay, now we can find the normal vector to the plane. So to do that, you just take the vector product of the two direction vectors we found. So it's just AB times AC. And to do that, you can do your IJK. Like you find the determinant of this. So first row would just be minus 5, 1, minus 2, and the second will be 1, 0, 2. Okay, so to evaluate this, you can actually just evaluate this in your calculator to save time, but I'm going to show you how to do it without a calculator because a lot of exam questions, they, give you the vectors in terms of like constants. Okay, so first of all, to find the I component, you cover up the rows and columns which have I in them. So it's basically this row and this row. And then you find the determinant of the remaining components. So 1 minus 2, 0, 2. So just cross multiply. So 1 times 2, that's 2. And then you minus the other cross multiplying product. So minus 2 times 0, that's 0. So 2 minus 0, you would get 2. And then now to find your j component, you minus j, okay? And then instead of covering up the I components, now you cover up the rows and columns that have j instead. So it's these two. And then you take a determinant of the remaining elements. So -5, -2, 1, and 2. So again, cross multiply, -5 times 2, that is -10. And then minus -2 times 1, that's minus -2. So -10 plus 2, that is -8. Okay. And then now we're gonna find a k component. So this is plus k. Okay. And now similarly, cover up the columns and rows with k in them and take the determinant. So for this is 0 minus 1 times 1, so 1. So 0 minus 1, you would get -1. Okay, so final answer would be 2i, which is 2 minus j times -8, that's just 8j, so 8, and then minus k, that's -1. So this is our normal vector to the plane. So we have found our a, b, and c values. So this would just be 2x plus 8y minus 1z equals to d. And to find this d, you just substitute any point in the plane. So either a, b, or c. So I'm going to substitute a. So a's coordinates is 0, 2, 3. So substitute x equals to 0 and y equals to 2 and z equals to 3. So there's 0 plus 8 times 2, 16, minus 3, that is 13. Hence, this is 2x plus 8y minus z equals to 13. So this is our final answer for this first part. Let's head on to the second part. Okay, so for this part, we're supposed to find the perpendicular distance from O to plane ABC. Okay, so to do this, let's sketch a diagram of this. So we'll let this be our plane ABC, and this would be our point O. And the perpendicular distance would be like this, okay? Like the line connecting from from O to ABC. The distance of this line would be the perpendicular distance. And the direction vector of this line, it would just be the normal vector of the plane. So using this, we can make a vector equation to find this point. Let's call this point P. Okay. So OP, that is just the position vector of O, which is 0, plus lambda or any scalar times the normal vector. Normal vector is 2, 8, 1. So just let it be lambda 2, 8, -1. So this is just 2 lambda, 8 lambda minus lambda. And okay, so now that we have the position vector of OP, now we can substitute the coordinates of OP into the equation of plane. Okay, so this is 2 times 2 lambda plus 8 times 8 lambda minus lambda equals to 13. And this would give you 4 lambda plus 64 lambda plus lambda. So 65 lambda plus 4, that is 69 lambda equals to 13. Okay, let me double check. Yep. Okay, so hence lambda would just be 1 over, never mind, it's just 13 over 69. Okay, so this is our value for lambda. Now we just have to find the distance of this vector OP. So to do that, we just have to take the modulus of OP and find the square root of 2 lambda squared, so 2 times 13 over 69, whole thing squared, plus 8 times 13 over 69, whole thing squared, plus minus 13 over 69 squared. Okay, so let me see. This would give you should give you 13 over 69 squared 69 units, or you can express it to 3SF as well, should give you 1.57 units. And this would be our final answer. For this part, let's head on to the next part. Okay, and for this final part, we're supposed to find the acute angle between the line OA and plane ABC. Okay, so now to do this question, let's again make a sketch. So we'll let this be our plane ABC, and this is our line OA. And now the question told us that we need to find the acute angle. Okay, we'll let the acute angle be theta. So to find this angle, we're going to find the angle between the normal of the angle between the normal of the plane and OA. Okay, so this would obviously be 90 minus theta because the normal of the plane is perpendicular to the plane. So this is 90 minus theta. Okay. Okay. Let's see if there's anything else. Oh, okay. So if we somehow get the obtuse angle between the normal and the line OA, so this is obviously just equal to 90 plus theta. Okay, so we'll get an obtuse angle when our dot product is negative. So with that, let's find our dot product. So this would be dot product of OA times the normal vector is equals to the modulus of OA times the modulus of n times cosine. I'll just leave this blank for now. Okay, so this is OA. So OA is just 0, 2, 3. And then n is just 2, 8 minus 1. And then modulus of OA, that is 0 squared plus 2 squared plus 3 squared square rooted. So that's 4 plus 9 square rooted, that's square root 13. And then the modulus of n, that is 2 squared plus 8 squared plus negative 1 squared. So that is 4 plus 64 plus 1. That is 69. So the squared 69. Cosine blank. Okay, so let's make the cosine blank the subject. So 0, 2, that is 0, and then 2 times 8, that's 16, and then 3 times negative 1, that's minus 3, so this will get 13. So this whole dot product is 13 over square root 13 over square root 69. And since our value of cosine cosine is positive, we can confirm that the angle between the normal and the line is not obtuse. So we can get rid of this case and we can make our cosine 90 degrees minus theta. So 90 degrees minus theta, and you write this as just square root 13 over 69. Okay, now let's make use of one property. Like this is called the complementary angle property. So let this be theta. And then this would obviously be 90 minus theta because it's a right angle. And we'll let this be ABC. So the cosine of 90 minus theta, that is obviously C over A. And what else is equal to C over A? The sine of theta, right? If you can notice, it's opposite over hypotenuse, opposite over hypotenuse. So we can rewrite this as just sine theta equals to square root 13 over 69. So just take the inverse sine, okay? And you can leave your answer in either degrees or radians. The question didn't specify. In my case, I'm gonna go with degrees. So in degrees, the answer is 25.7 degrees to 1 decimal place. All answers to degrees should be given to 1 decimal place. So this is our final answer for this part, as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that the cubic equation, this, where B and C are constants, they have the roots alpha, beta, and gamma. And we're also told that this whole matrix is singular. So singular basically means that the determinant of this matrix is equals to 0, and hence you cannot find so the inverse of this matrix doesn't exist. Okay, so for the first part, we have to show that this result is true. Okay, so, all right. In order to do this, let's see. Yep, okay, so in order to do this, let's first equate alpha squared plus beta squared plus gamma squared as the sigma alpha squared. And for this, there's actually a general formula for sigma alpha squared. It's just bracket sigma alpha squared. So bracket sigma alpha is just, the sum of roots. So just alpha plus beta plus gamma times minus 2 times sigma alpha beta. So this is the sum of the root pairs. So alpha beta plus alpha gamma plus beta gamma. Okay. Yeah. So see if we can use the formula. Okay, the formula doesn't seem very useful. Okay, let's just find the determinant of the inverse. So let's take the determinant of this matrix. So to find the determinant of this, you sorry. Okay, I can't remember. So you multiply by the first row, first column element, so 1. So multiply by 1, and then you cover the rows and columns that have 1. And then you take the determinant of the remaining elements. So 1 gamma gamma 1. Okay, and then the second step is to take minus alpha, which is the second element of the first row. And again, you cover up the rows and columns with this element on it. So this and this, and you take the determinant of the remaining components. So alpha, gamma, beta, 1. All right. Now, finally, you take times beta, so plus beta, which is the final row, which is the final element of the final row. Okay, and then you cover these up, and you take the determinant of the remaining elements, so alpha, 1, beta, and gamma. Okay, so let's evaluate this. So this is 1 times, just take the cross product, so 1 minus gamma times gamma, so that's just gamma squared, minus alpha, alpha times 1, that's alpha, minus gamma times beta, that's beta gamma, and for beta, this is alpha gamma times minus beta. It equals to 0. Okay, now let's expand this. So 1 minus gamma squared minus alpha times alpha, that's minus alpha squared, and minus alpha times minus beta gamma, that's plus alpha beta gamma. Then this is just alpha beta gamma. This is minus beta times beta, that's minus beta squared, equals to 0. Okay, now let's make this expression the subject of this equation. So we'll move all the alpha squared, beta squared, and gamma squared to the left-hand side of the equation. So this would be alpha squared plus beta squared plus gamma squared equals to alpha beta gamma plus alpha beta gamma. That's just 2 alpha beta gamma minus 1. Okay, so let's evaluate what alpha beta gamma is. So as you know, alpha beta gamma is just the product of the roots. And the product of the roots you get by taking your coefficient of the constant. So for sigma alpha, sum of roots is minus b over a, where a is the coefficient of x cubed. And then for the sigma alpha beta, that is c over a. Then for sigma alpha beta gamma, the product of roots, that's minus d over a. So in this case, d is minus 1. So minus d, that's 1 over a, which is 1. So this is just equals to 1. Okay, so this is minus 1 over 1. Hence, we can evaluate this 2 times 1. Okay. Sorry, this is supposed to be plus 1. 2 times 1 plus 1, we'll get 3. This is shown. So this is our final answer for the first part. Let's head on to the next part. Okay, so we're now told that alpha cube plus beta cube plus gamma cube is equals to 3, and the constants b and c are positive. And we're supposed to find the values of b and c. Okay, so to do this question, all right, let's form equations in terms of b and c first. So using this piece of information, let's first let a to the power of n plus b to the power of n plus gamma to the power of n equal to Sn. And we'll use this relation to, we'll use this our original cubic equation to substitute this in. Okay, so x cubed, that would just be S3, and then bx squared, that would just be b times S2, and then plus cx, that would just be plus cs1, and then minus 1, that would just be minus 1 times s0 equals to 0. Go and check. Yep. Okay, so we know s3, that is 3, and then s2 is also 3, so this is just 3b, and then s1 is just, alpha plus beta plus gamma. So alpha plus beta plus gamma, just minus b over a. So minus b divided by 1. So that's just minus b minus s0. So s0, that's just 1 plus 1 plus 1, which is minus 3 equals to 0. Okay, so the 3 and 3 cancels out, and you get 3b minus bc equals to 0. Okay, so we have a common factor we can factor out here. Let's factor out b. So b is 3 minus c equals to 0. So we can either have b equals to 0 or 3 minus c equals to 0, and then c would be equals to 3. But we're told that b and c are both positive, so we have to reject this solution. Okay. All right. So this is our value for c. Okay. All right. To find the value for b, we're gonna have to make another equation, the one that we tried using in the previous part for S2, which is alpha squared plus beta squared plus gamma squared. So this would be equals to minus alpha bracket sigma alpha whole thing squared. So that's just S1 squared minus 2 times sigma alpha beta. So that's just alpha beta plus alpha gamma plus beta gamma. Okay, so this is S2. So S2 found out is 3. And then S1 is minus b squared. So just b squared minus 2 alpha beta. So beta is c over a. So just c. C divided by 1, so 2c. Okay. All right, and now we're going to substitute our c value. So 2c, that's 2 times 3, which is minus 6, equals to 3. Then we will get b squared equals to 9. And then b would be equal to the square root of 9, which is 3 also. So this is our final answer for c and b, both of which are 3. So this is our final answer for this part. Let's head on to the next question. Okay, so for this next question, we're told that the matrix M represents a sequence of 2 transformations in the xy plane, given by a one-way stretch in the x direction, scale factor 3, followed by a reflection in the line y equals to x. And for the first part, we have to find M. Okay, so to find M, we're gonna have to first know the 2 matrices that, that represent the 2 transformations that M represents. So the way we do this is, so this would be the first one, and then this would be the second one. So it's like, opposite. Yeah, so the first one is a one-way stretch in the x direction, so horizontal stretch with scale factor 3. So this would just be in the form K1, 0, 0. So this would be 3, 1, 0, 0. And one way to know this, to remember this, is to think 1100. Okay, this is your identity matrix, and this is your X and Y coordinates, so-called. So a horizontal stretch, you would change the number here to the scale factor, and then vertical stretch, you would not change the top number, you only change the bottom number. So this would be 1, 3 if it was stretch in the Y direction of scale factor 3. So this is one way to remember this. Okay, and then oh wait, sorry. It's not supposed to be here. It's supposed to be 3, 0, 0. Okay, now for the reflection in the line y equals to x, it's given by this opposite one, so it's 0, 0, 1, 1. And how to remember this is that is the exact opposite of 1, 0, 0, 1. So basically all the elements, they switch places. So for the first row, the 0 and 1 switch places, and same for the second row. And then for reflection in the line y equals to minus x, the ones, they become minus 1. Yeah, so this is how I remember for this. So this is 0, 0, 1, 1. Okay. All right. So now we're ready to multiply these two matrices. And again, you can just do this on your calculator, but yeah, I'm gonna do it the manual way because a lot of times you're given constants instead of numbers. So to do this, take your number of rows and then the number of columns for the first matrix, and then do the same for the second matrix. So number of rows and number of columns. So this is a 2 by 2 matrix. Now you combine the number of columns of the first matrix and the number of rows of the second matrix. If they match, you can multiply them. And this would be the dimensions of your resultant matrix. So this would also be a 2 by 2 matrix. So 2 rows and 2 columns. Okay. Yeah, and then now to find the elements. For the first element, since it's in the first column, first row, you take the first column of the first matrix, and then you multiply it by the first row of the second matrix. So this would be 0 times 3, which is 0, and plus 1 times 0, which is also 0. So this is just 0. And then for the next one, so it's in the first row, second column. So wait. Oh wait, sorry. Sorry, you take the row and then the column. Okay, so you just erase all the circles. Okay, so for the first element, you multiply the first row by the first column of the second matrix. So this is 0 times 3, which is 0, plus 1 times 0, which is 0. And the answer doesn't change. And for the second row, since it's in the first row, second column, you multiply the first row by the second row. So this is 0 times 0, which is 0, and then plus 1 times 1, which is 1. So this is 1. And then for the third element, it's in the second row and first column. So you multiply by the second row and the first column. So this is 1 times 3, which is 3, plus 0 times 0, which is 0. So 0 plus 3, that's 3. And then for the final element, it's in the second row, second column. So you multiply second row and second column. So 1 times 0, that's 0, plus 0 times 1, which is also 0. So that is 0. So this is our final answer for this part. And as usual, you can use a calculator to check whether your answer is correct. So without further ado, let's head on to the next part. Okay, so for this part, we're supposed to give full details of the geometric transformation in the xy plane represented by M inverse. Okay, so to do this, let's express M inverse in terms of a product of two matrices. So since we know that M is equals to these two matrices, this M, okay, we'll let this be A and this be B. So M is equals to B. Hence M inverse B, and use this relation is B inverse A times A inverse A. So again, it's opposite. Okay, so let's find M inverse A by finding B inverse A. So B inverse A, to find it, you take 1 divided by the determinant of B, which is just the multiple of the diagonals. So you take the first diagonal, 3 times 1, that's 3, and then you minus by the second diagonal, 0. So that's just 1 over 3 times, you swap these two. So this is 1, 3, and then you multiply by negative 1 for the second diagonal. So this is 0, 0. And then this is times A inverse. So A inverse is also the same. You divide 1 by the determinant of A. Okay, so A, sorry, it's just 1, 0, 0, 1. Okay, so 0 times 0, that's 0, and then minus 1 times 1, that's minus 1. So yeah, and then times, uh, you swap these elements. So this is 0, 0, and then you minus 1 from these elements times 1 by these elements. So 1, 1. Okay, now let's find the final matrices. So just multiply 1/3 by every element in this matrix. So this is 1/3, 0, 0, 1. This is 1 over minus 1, that's minus 1. So just multiply minus 1. So you get 0, 1, 1, 0. Okay, and now we can see the geometrical transformations that it represents. So this is the first one, and followed by the second one. So the first one, this is obviously a reflection over the line y equals to x. So we can say reflection over the line y equals to x. And then this is followed by the second transformation, followed by, so it is actually a stretch in the x direction of scale factor 1/3, followed by, I'm just going to write horizontal stretch, scale factor 1/3. So if you realize, it's basically the opposite of the transformation represented by M, okay? But if you don't remember, you can always do this process to, be extra sure of your answer. So this is our final answer for this part. Let's head on to the next part. Okay, so now we're told that the matrix N is such that Mn is equals to this matrix. And for this part, we're supposed to find N. Okay, so to do this, let's first write the equation that we're given. Mn is equals to 1, 2, 3, 2. And to isolate M, you have to take M inverse on both sides. So you take M inverse on the left-hand side. And you also multiply by M inverse on the left-hand side on the right-hand side, okay? You have to be consistent because matrix multiplication is non-commutative. So AB isn't equals to BA. So be mindful of that. And M inverse times m, it just give you the identity matrix. And any matrix multiplied by the identity matrix or the other way around will just give you the matrix. So this is n that's equals to m inverse times 1, 2, 3, 2. Okay, now let's evaluate m inverse. So m inverse, we found it in terms of the products in here. So now we're gonna evaluate this. Okay, so this would be a 2 by 2 matrix. So for the first row, it will be in the first row, first column. So first row, first column. So this is 1/3 times 0, that's 0, plus 0 times 1, that's 0. So 1/3. And then 1/3 for the next one, it's the first row times the second column. So 1/3 times 1, which is 1/3, plus 0 times 0, which is 0. So again, that is wait a minute. Times 0, that's 0. Oh, this is supposed to be 0. And this is supposed to be 1/3. Okay, and then for this third element, it's in the second row, first column. So 0 times 0 plus 1 times 1, which is 1. And then for the final element, this is second row times second column. So 0 times 1, that's 0, plus 1 times 0, that is 0. So 0 plus 0, that's 0. Yeah, so this is m inverse 1. You can check using your calculator by finding m inverse 1 directly from m. Okay, so anyways, this is n equals to 0, 1/3, 1, 0 times 1, 2, 3, 2. Okay, you can use your calculator to find this or do it, manually. So this is, okay, so 0 times 1, that's 0, plus 1/3 times 3, that's just 0 plus 1, which is 1. And then 0 times 2, that's 0, plus 1/3 times 2, that is 2/3, which is 2/3. For this would be 1 times 1, which is 1, plus 0 times 3, which is 0. So that's 1. Now 1 times 2, that is 2, plus 0 times 2, that is 0. So that would be 2. So this is our final answer for this part. Let's head on to the final part. Okay, so for this last part, we're supposed to find the equations of the invariant lines through the origin of the transformation in the xy plane represented by Mn. Okay, so to do this, we must know what an invariant line is. So an invariant line is a line that doesn't change after a transformation has been applied or after it has been multiplied by a matrix. So let's take the point xy. Okay, so this, say it's multiplied by this 2 by 2 matrix. Okay, this will still be xy if it's like invariant. And the origin is always invariant regardless of what transformation you apply. Okay, so using the same concept, we're going to multiply Mn, which is 1, 2, 3, 2, with xy. And then the new coordinates will just be big X, big Y. By the way, these two are the same. Yeah. And since they're passing through the origin, we can equate y equals to mx and big Y equals to m times big X. So let's do that. X equals to big X mx. Okay. Now let's multiply these. It's a 2 by 2 matrix. It's a 2 by 1 matrix. So the number of columns and number of rows line up. So this would be a 2 by 1 matrix. So let's make space for that. So now let's multiply. So first one, to get it, multiply the first row by this column. So 1 times x, that's x, and then plus 2 times mx, that's 2mx. Then 2 times xmx, that's 3x plus 2mx. Okay, now we just convert this into a fraction by equating the components. So this would be x plus 2mx divided by 3x plus 2mx equals to x over mx. So we can cancel out the big x's as well as the small x's on the left hand side. So factor out x, yeah, we'll get 1 plus 2m over 3 plus 2m equals to 1 over m. Now let's just cross multiply. So this would be m times 2m plus 1 equals to 2m plus 3. It'll be 2m squared plus m equals to 2m plus 3. Let's move everything to the left hand side. So this is 2m squared plus m minus 2m minus 3 equals to 0. It's just 2m squared minus 2m plus m, that is minus m minus 3 equals to 0. So this is a quadratic equation. So you can try to either factorize it or, use quadratic formula. So I'm going to try factorizing it. So we got 2m minus 3 and m plus 1 goes to 0. Now just equate each factor to 2. You'll get m equals to 3 over 2 and m plus 1 equals to 0. You'll get m equals to negative 1. So substituting into these two equations, you will therefore get y equals to 3 over 2x and y equals to negative x as your final invariant lines. So these two are our final answers for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that the curve C has this polar equation, r equals to a tangent 1 over a theta, where a is a positive constant and theta is between 0 and 2 pi. So for the first part, we have to sketch C and state in terms of A the greatest distance of a point on C from the pole. Okay, so in order to sketch a polar curve, you first have to draw the initial line, which is almost like the x-axis when we're drawing normal Cartesian curves. So the initial line has the equation theta equals to 0. And the beginning of the initial line, that's called the pole. It's almost like the origin, basically. Okay, so to sketch polar curves, you basically, do a table of values. So you take values of theta and r. So r is like the distance from the pole to the point. So theta equals to 0, you get tangent 0, you get r equals to 0. And then theta pi over 12, you get a tangent 1 over 8 times pi over 12. You get 0.32. You don't have to write it down. You can just type into a calculator and see whether the value increases or decreases. Pi over 6, 0.6, yeah, so it's increasing. And then pi over 4, 0.9, pi over 3, 0.13, pi over 5 over 12, 0.165. Okay. Let's substitute 2 pi. You get 1, okay? So basically you get A. All right. Yeah, so basically the distance from the pole increases as the value of theta increases. So theta is the angle of the point between like the line from the point to the pole and the initial line. So it's gonna basically be like this. Okay, this could be an accurate sketch. But let me try drawing it again. Start off very small and it will just increase like this. So this is r equals to a tangent 1 over 8 theta. Okay, all right. And now we can write down r equals to a tangent 1 over 8 2 pi, which is equals to a. This is the greatest distance. The greatest distance is when theta equals to 2 pi. So this is our final answer for this first part. Let's head on to the next part. Okay, so this part we have to find in terms of A, the area of the region bounded by C and the initial line. So what they're talking about is basically this entire area over here. So to find the area enclosed by a polar curve, it's just half times the integral of r squared with respect to theta. And for the limits, it would basically be your minimum and maximum values of theta. So between 2 pi and 0. Okay, so let's evaluate what r squared is first. So r squared is a squared times tangent square 1 over 8 theta. And to make this into an integratable form, a form where you can integrate, let's use our trig identities. So we know 1 plus tangent squared theta is equals to secant squared theta. It's in your MF19, okay? Yep, right here. So we're going to use that. So make tangent squared the subject, you get 1 minus secant square 1 minus theta. Secant square 1 over 8 theta. All right, so now let's substitute this. So this 2 pi 0 a squared times 1 minus secant square 1 over 8 theta, d theta. And now we'll take out the constant terms. So one of them is a, so a squared over 2 pi 0, 1 minus secant square 1 over 8 theta d theta. Okay, so now let's integrate this. So let's integrate 1 first. So that's just theta, and integrating secant square 1 over 8 theta, that is 1 over 8, so minus 8 tangent 1 over 8 theta 2 pi 0. So substituting 2 pi, you get 2 pi minus 8 tangent 1 over 8 times 2 pi, that is pi over 4, and then minus 0 plus 8 times tangent 0. So that's just 0. So, okay. So simplifying this, it's just 2 pi minus 8. Tangent pi over 4 is 1. Okay, and then expanding this, you get pi a squared minus 4a squared, unit squared. So this is our final answer for this part. Let's head on to the next and final part. Okay, so for this final part, we have to show that at the point on C, furthest from the initial line, that this result is true. And we have to also verify that this equation has a root between 4.95 and 5. Okay, so what do they mean by the point furthest from the initial line? So let's take a look at our graph. So this is the initial line, and the line furthest from the initial line has the largest vertical displacement from the initial line. So in the Cartesian plane, this is basically like the, the biggest y value or the smallest y value. Yeah. So to find this out, we're going to have to equate dy d theta equals to 0. Kind of almost like how to find maximum minimum point. You have to equate dy dx equals to 0. Okay, so to do this, let's first find the expression for y in terms of theta. So y is equals to r sine theta. So r is a tangent 8 theta, tangent 1 over 8 theta, sine theta. All right, and then dy d theta, just the differential of this. So let's take out any constant terms that we have. So we have a. Now you just differentiate this tangent 1 over 8 theta and sine theta. So tangent 1 over 8 theta, let's differentiate that first. So you would get 1 over 8 secant square 1 over 8 theta and keep sine theta. And then you now add it with the derivative of sine theta, which is cosine theta. And then you multiply it with tangent 1 over 8 theta. Okay. All right, now let's express this whole thing in terms of just sine and cosine. Okay, so this secant 1 over 8 we can rewrite as 1 over 8 cosine square 1 over 8 theta. And then this is times sine theta plus cosine 1 over 8 theta, cosine theta, sine 1 over 8 theta. Now let's make the denominator same. So this is 1 over 8 cosine square 1 over 8 theta, sine theta plus 8 cosine 1 over 8 theta. That is 8 cos theta sine 1 over 8 theta, 8 cos 1 over 8 theta. Okay. Now let's equate this to 0. So let's multiply by the denominator and divide by a. You would get sine theta plus cosine theta 8 cosine 1 over 8 theta sine 1 over 8 theta equals to 0. Okay. Now to simplify this, let's look at our double angle formula for sine. So sine 2 is equals to 2 sine A cosine A. So let's factor out 4 from here to get 2 cosine 1 over 8 theta sine 1 over 8 theta equals to 0. And this would be equal to just sine 2 times 1 over 8 theta. So sine 1 over 4 theta equals to 0. Okay, now we just have to do a bit of rearranging. So this is 4 sine 1 over 4 theta cosine theta plus sine theta equals to 0. And this is the exact result that we're required to show. So we can write shown. And to now do the second part of this question, the verification, we're just going to substitute the two values. So first let's sub theta equals to 4.95. So we'll get, just show that you're substituting. Plus sine 4.95 sine theta 4.95. Okay. Okay, so 4.95. So 4 sine 1 over 4 answer, cosine answer plus sine answer. You would get a negative value. Express it to 3SF. So just say 0 and also now substitute the second value, 5. So this is going to be 4 sine 5 over 4 cosine 5 plus sine 5. This is going to be 0.118. And this is more than 0. So hence you can conclude that since there is a sign change, the root lies between 4.95 and 5. Verified. So this is our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so in this question, we're told that the curve C has this equation. And for the first one, we have to state the equation of the asymptote of C. Okay, so to do that, let's analyze this function. So the degree of this, the numerator is 2. I mean, it's a rational function, and the denominator is also 2. So hence, this would have a horizontal asymptote because the degrees of both the numerator and the denominator are the same. So to find that out, just divide by the coefficients of the terms with the highest power. So in this case, x squared. So it's just 1 divided by 1. So you'll get y equals to 1. And the reason why there is no vertical asymptote is because when you equate the denominator to 0, you will not get any real solutions. So this is, sorry. So this is our final answer for this part. Let's head on to the next part. Okay, so now we have to show that for all real values of x, y lies in this range. Okay, so to do this, let's first write down our original equation. And now we're going to make a quadratic where the coefficients are in terms of y. So start by multiplying by the denominator. So this is going to be yx squared plus yx plus 2y equals to x squared plus x plus 4. Now move all the terms to the left-hand side. So be yx squared minus x squared plus yx minus x plus 2y plus 4 equals to 0. Now factor out the x squared, you get y minus 1 x squared. Factoring out the x, you get y minus 1 x plus 2y plus 4 equals to 0. Yes, so as you can see, we have a quadratic in terms of x, and the coefficients are in terms of y. So now we're going to use the discriminant, b squared minus 4ac, and we would equate it to less than or equal to 0. All right. Because for this value, x would have real solutions. So b squared is y minus 1 squared minus 4 y minus 1, that's a, and then c is 2y plus 4. So y minus 1, that's y squared minus 2y plus 1 and minus 4. Factoring out the 2 from 2y plus 4, you get 8. Then this is y minus 1 times y plus. Okay, never mind. Let's just expand it directly. Yeah, minus 4 y times 2y, that's 2y squared. Minus 1 times 2y, that's minus 2y. And then 4y, that's plus 2y minus 4. Then it goes to 0. So minus y squared plus y squared, that's minus 7y squared. And minus 2y minus 8y, that's minus 10y. And then 1 plus 16, that is plus 17, less than 0. And we can rewrite this as 7y plus 10y minus 17 more than 0. Okay, so to solve this inequality, let's first try factorizing it. Should be able to factorize it. Yeah, so we got y minus 1 and 7y plus 17 more than 0. Okay, now let's sketch the quadratic function. Let's write down the root. So this is 1, and then this is minus 17 over 7 more than 0. So we're going to have to look at the region above the above the x-axis. So this is the region we're interested in. Oh, sorry. This is supposed to be okay. All right. This is supposed to be more than or equals to 0, because if you equate it to less than or equals to 0, you'll find the values of x for which y doesn't exist. Okay. And I mean the values of y for which x doesn't have any real values. Okay. So less than 0, less than 0. Yeah, so we have to look below the x-axis. So hence our answer is between 17 over 17 equals to y and less than 1, since we already know that y equals to 1 is an asymptote. So this is our final answer, right down shown for this question. Let's head on to the next part. Okay, now we have to find the coordinates of any stationary points of C. Okay, so to do this, I'm just going to directly integrate the function. So dy dx, since it's a rational function, we'll use the quotient rule. So this would be x squared plus x plus 2 whole thing squared. And then keep the denominator and multiply by the derivative of the numerator. So this is just 2x plus 1 and then minus x squared plus x minus 4 times the derivative of the denominator, that's 2x plus 1. Okay, now we can just directly, equate the numerator to 0. So let's first factor out 2x plus 1 from the numerator. So it would be x squared plus x plus 2 minus x squared minus x plus 4 equals to 0. So the x squares cancel out, and as well as the x's. Okay, this is equals to 0. So this is 2x plus 1 times 2 plus 4, that is 6, equals to 0. Okay. All right. Mm. So we'll get 2x plus 1 equals to 0, and hence x is equals to minus half. Okay, and now let's substitute into the equation. Okay, y would be equals to minus, yeah, never mind, let's just show a substitution. Y, x squared plus x minus 4 over x squared plus x plus 2. Okay, and then this is equals to answer plus that, answer squared plus answer plus 2. This is minus 17 over 7. So this is the only stationary point. The coordinates is minus half and minus 17 over 7. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're supposed to sketch C, stating the coordinates of the intersection with the axes. So we're supposed to state the coordinates of the x and y intercepts. Okay, so C, sketch C. Let's first draw our x and y intercepts. And by the way, when you're doing this in the exam, please use a ruler and don't use a freehand like me. Yeah, so the asymptote, we only have one asymptote, which is y equals to 1. So let's sketch that. Y equals to 1. And then, yeah. Okay. So we only have one stationary point, which is minus half and minus 17 over 7. So that would be somewhere here. Okay. All right, and yeah, let's look for x coordinates, like the y-intercept. So just substitute x equals to 0. So 0 plus 0, minus 4. And over 0 plus 0 plus 2, that's 2. So minus 4 over 2, you get minus 2. So 0 minus 2. Okay. Okay, so This is 1, and this would be 0 minus 2. And then this would be the stationary point. Okay, now equate the numerator to 0. X squared plus x minus 4 equals to 0. You can just do it straight onto your calculator. You don't have to show the working. It's 1 minus 4. Okay, you get one coordinate, 1.56. So that is somewhere here. This is squared 17 minus 1 over 2, 0. And then the other coordinate that is further down. Okay, so label that as well. That is minus 1 minus squared 17 over 2, 0. Yeah. Okay, now we can sketch. So, oh, sorry. Okay, and then this is the turning point. Okay. Yeah, so this is our curve, our final answer. Let's head on to the next part. All right, so now we're supposed to sketch the graph with this equation. So basically it's the same equation, but now all the x's, they have been, the modulus function has been applied to every x. So it's not that the whole function is under the modulus function, but only the x's. And we have to find the set of values of x for which this is equals to minus half. Okay, so to sketch this equation, we just take the positive part of the curve, like the part of the curve which is towards the right-hand side of the y-axis, and you reflect that part of the curve over to the other side of the, curve. So let's do that. So this is y, this is y and x. Okay. So we can just like sketch roughly. It's like this. Okay. So you're supposed to reflect this part towards the right-hand side of the y-axis. Okay, and then you're supposed to reflect it over to the left-hand side. So you ignore everything that's towards the left-hand side and just reflect it. Yeah. So this would be something like this. So it's like a shape is like a bird flying. Like when you like it's like the shape of the bird, flying you drew when like you were a kid. Yeah, so this is like the shape. Yeah, and now using this, we can find the set of values of x for which this is minus half. So we know that this is 0, negative 2. So let's sketch the line y equals to negative half. Y equals to negative half is obviously here. Okay. So to find the points, we have to find these two critical points first. So to find the values of x, we find this value first. And then this value would just be this value times negative 1. So let's find that value first. Okay, so to do that, just take your original equation without the x's being under the modulus sign, and you equate it to minus half. So by doing that, you'll get this point on this part of the curve. Okay, you'll get this x coordinate in here. So let's solve for it. So Cross multiplying, you get 2x squared plus 2x minus 8 equals to minus x times minus x minus 2. Move everything to the left-hand side, you get 3x squared plus 3x minus 6. Yeah, equals to 0. All right, and now just factorize. Okay. Simplify. So divide by 3. You get 3 times 1 plus 1 minus 2. So you get x minus 1 and x plus 2. Hence the critical points would be x minus 1 equals to 0, x equals to 1, or x plus 2 equals to 0, which is x equals to negative 2. But we're going to reject this because we know from our graph that x has to be positive because it's towards the right of the y-axis. Okay, so hence our final answer would just be between minus 1 and 1. Yeah, so this is our final answer for this part and this entire question. And we've also come to the end of the question paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel and share this video with anyone you know might find this helpful. And if you have any queries or doubts or improvements that I have to make in this video or any future video ideas, feel free to leave them down in the comments below, and I'll see you again next time. Okay, thank you.